For most of human history, we looked up at the sky and made a very logical assumption. We are the main characters. In mythologies across the world, people believed their flat Earth sat dead center, anchored to the heavens by a great cosmic pillar, or axis mundi. Eventually, early scientists mapped this intuition. Philosophers like Aristotle and Ptolemy formalized a mathematical picture of reality known as the geocentric model. In this system, Earth was a stationary anchor. The sun, moon, planets, and stars all rotated around us in perfect, predictable rings. To them, it was a neat, orderly cosmos. For thousands of years, our map of reality placed us right where we felt we belonged. But that ego took a hit in the 16th century. The Copernican revolution proved that Earth is actually just another planet orbiting the sun. We lost the center of the universe, handing the title over to our local star. A couple of centuries later, astronomers analyzing the night sky realized the sun is just one of billions of stars swirling inside the Milky Way. So, the hypothetical center of the universe shifted once again, this time pointing to the dense core of our galaxy. By the 1920s, scientists were confident they had the final picture. The consensus held that the Milky Way galaxy was the entire universe, a solitary, massive island floating in an endless void. Then, an astronomer named Edwin Hubble analyzed the light from distant, pulsating stars. In 1925, he proved that fuzzy clouds visible in our telescopes were actually completely separate galaxies, lying millions of light-years outside the Milky Way. But Edwin Hubble noticed something even stranger. By studying the light signatures of these newly discovered galaxies, he found that almost all of them were rushing away from us at extremely high speeds. If every single other galaxy in the cosmos is clearly retreating from Earth right now, it raises an obvious physical question. Are we actually standing at the true center of the universe after all? This diagram shows the true nature of expansion. Every galaxy gains distance from every other because the fabric of space itself is stretching out. By running this process in reverse, rewinding 13.8 billion years, all of space compresses into an incredibly hot, dense singularity. This creates a strange spatial paradox. Space didn't expand outward from a single point sitting inside a larger void. Space was that point. Because all of space expanded from that shared moment in time, there is no distinct geographic center left behind today. To an observer standing in our Milky Way, everything appears to be retreating from them, but an alien in a galaxy 10 billion light-years away would see the exact same thing, every other galaxy rushing away from their position. The Big Bang occurred at every point in space simultaneously. Since all matter and energy originated from that shared singularity, every location in the cosmos is currently the center of the universe. If the universe is an expanding fabric with no edges and no center, it leaves astronomers with another massive physical mystery. What is its overall three-dimensional shape? This model displays the three mathematical possibilities, dictated by density. Space could be a closed sphere, an open saddle, or a flat plane. If closed, space curves back in on itself. A spaceship flying straight would eventually circumnavigate reality, returning to its starting point. To find out which shape we live in, astronomers use specialized satellites to observe the cosmic microwave background, the oldest light remaining from the Big Bang. By studying these temperature fluctuations, researchers perform massive-scale trigonometry to calculate the true density of space. The data provides a clear verdict. The cosmos possesses a Goldilocks density, roughly 6 protons per cubic yard. It expands uniformly in all directions, without curving positively or negatively. Practically, that means the universe is perfectly flat. If you launched 2 rockets side by side on parallel paths, they could fly forever without their trajectories ever intersecting or pulling apart. Just as scientists mapped this flat, expanding geometry, astronomers studying distant supernovas shattered expectations of how this universe should behave over time. Take a look at this graph tracking the cosmic expansion rate. For the first half of the universe's life, the collective gravity of all matter caused the expansion to slow down, gently curving downward. But about 7.5 billion years ago, the line violently hooks upward. The expansion was kicked into overdrive, and it is actively accelerating. As this chart shows, Understanding how this acceleration is possible requires looking at the recipe of the cosmos. Everything we can observe, the stars, the planets, the dust clouds, and us, accounts for less than 5% of reality. The rest is composed of invisible forces. Dark matter makes up 27%, acting as the gravitational glue holding galaxies together. But an overwhelming 68% is dark energy, a mysterious, undetected force, acting as the engine pushing our flat universe apart at ever-increasing speeds. The vast, brilliant cosmos we observe through our telescopes is merely the bright foam floating on top of a deep ocean of dark, invisible forces. This is the ultimate extension of the Copernican principle. Earth is absent from the center of the solar system, and humanity holds no privileged location in space, in time, or even in the material composition of reality itself. We are passengers floating through a centerless, expanding void, utilizing extraordinary technology to stare out into an accelerating darkness we are only just beginning to map. Losing our seat at the center of reality offered a profound trade-off. We gained an infinitely bigger and more beautiful mystery to solve.